Okay guys, go back to mathematics. Today we are going to prove this theorem, which is properties of inequalities. Just like what I did in the previous video, I have proved these properties. Properties of inequality start from the assumption with greater than. Right now, we are going to inequality properties with the assumption less than. Okay, now let's take a look. We start with the first one, number one. Yeah. So what I want to do is I want to let a, b, c, x, y be integers. Then I will prove the first properties. For the first property is that if a less than b, then a plus c is less than b plus c. So we have to show that this inequality, right, hold. Okay, when a is less than b. This means that we can add both sides by a constant c, which is an integer. So for the first one, I have to assume that a is less than b. Okay, and do not forget that according to definition of inequality, less than. Okay, a is less than b if and only if b is greater than a. Okay, and b is greater than a by definition if and only if b minus a is contained in the set of natural number. So for this one, we have to make sure that a and b are an integer. All right. So since we have a less than, but we have the definition of greater than. So from this one, this implies that b is greater than a. And when b is greater than a, so we gotta have b minus a is contained in the set of natural number. Okay. Now we want to have this inequality, a plus c less than b plus c. So we have to show that b plus c, right, greater than a plus c first. Okay. To show this inequality, we have to have b plus c minus a plus c contained in the set of natural number. All right, so we have to start with b plus c minus a plus c. So what do we have here? I will distribute minus sign. So we're gonna have b plus c minus a minus c. Then it turns out to be b plus minus a plus c minus c. C minus c is 0. So we're gonna have b minus a plus 0, which is b minus a. And we know that b minus a is contained in the set of natural numbers. Okay. Hence, we have shown that b plus c minus a plus c is contained in the set of natural number. Right? Because this one here becomes a minus b. And a minus b is in the set of natural number. So once we have this one, B plus C, what does it imply? So this implies that B plus C is greater than A plus C. And hence, A plus C is less than B plus C. That's it. Alright, that's it. That's the first property of theorem 1.1.4. Okay, similarly, try to do the second one. Let's prove property number 2. Okay, property number 2 here. Alright, yeah. So if A is less than B and B is less than C, we can have A less than C. So we have to assume that. Assume that A is less than B and B is less than C. And try to show that A is less than C. So what do we have right here? So we're gonna have B greater than A and B greater than C. So by definition of greater than, what do we have? So we're gonna have B minus A is in the set of natural number, and B minus C is in the set of natural number. Now we have two natural numbers, B minus A and B minus C. So according to trichotomy law here, okay, let me recall trichotomy law. A set of natural number is a subset of a set of integer. Satisfy the following properties. Number 1, 0 is not in a set of natural number. Number 2, any two elements in a set of natural number, the sum is in a set of natural number. Its product is also in a set of natural number. If you pick up, for the third one, if you select an integer, then what do we have? That integer can be positive integer. That integer can be 0. Or that integer can be negative. Okay? So, we will use the second one, trichotomy law. The second one of trichotomy law. So, by trichotomy law, second one, what do we have here? By the way, we want to show that A less than C. Okay, so I want to start with I just want to start with C minus A. And for C minus A, I want to do this. Minus B and plus B or the middle. Then what do we have here? Okay, what do we have here? Give me a second. B less than C. This implies that C greater than B. I'm terribly sorry, guys. C greater than B, okay? C greater than B. This means that we're gonna have C minus B in a set of natural number. Oh. Okay. Right now, the steps are all correct. Alright? So, let's go to here. B minus C, C minus B is a set of natural number. B minus A is in the set of natural number. What does it mean by this? We have two natural number. We have the sum of two natural number. Okay? And the sum of two natural number is also a natural number. So this implies that C minus A is in the set of natural number. Okay? So, what do we have? What does it mean by this? This means that C is greater than A. And C greater than A, what does it imply? Hence, A is less than C. Okay? A is less than C. That's what we have. Alright? Okay. The third one. Let's prove the third one. So if A is less than B and X is less than Y, then A plus X is less than B plus Y. So with this assumption, we have to show this inequality. Alright? So assume that we have to assume that A less than B and X less than Y. Then what do we have? So let's change less than into greater than. So we're gonna have B greater than A and Y greater than X. By definition of greater than, what do we have? So we gotta have B minus A is in the set of natural number and Y minus X is in the set of natural number. But we want to prove this inequality. A plus X less than B plus Y. Okay? So we have to show that B plus Y is greater than A plus X first, right? So let's start with this. Okay? We will use trichotomy law. So by trichotomy law, okay, what do we have? So I want to start with B plus Y minus A plus X. So we want to show that A plus Y minus A plus X is in the set of natural number. So we gotta have B plus Y minus A minus X and use commutative property. So we gotta have B minus A plus Y minus X. Right now, these are two natural numbers. According to trichotomy law, the sum of two natural numbers is also a natural number or positive integer. So with this property, we have shown that B plus Y minus A plus X is in the set of natural number. Right? Okay, B plus Y minus A plus X is in the set of natural number. Therefore, okay, or thus, B plus Y is greater than A plus X. And B plus Y greater than A plus X, what does it define? Okay, what does it imply? Right? So by definition of integer, A plus X will be less than B plus y. That's it. Okay, that's the third one. Now what about the fourth one? The fourth property. The fourth property. Here. If a is less than b and x is greater than 0, multiplying both sides of inequality by a positive integer never change the direction of inequality, right? So let's prove this theorem. Let's prove this property. Okay, let's continue. Let's prove this. Yeah. Okay, the fourth property. So we have a less than b and x greater than 0. So I have to assume that a is less than b and x is greater than 0. Okay? So what does it imply? This is by definition of less than, right? A less than b implies that b greater than a. Okay? And x is greater than 0. Okay. X is greater than 0. And since a and b are integer and x are also integer, x must be a positive integer. So, by definition of greater than, okay, b minus a is in the set of natural number, and x is also in a set of natural number. But we want to show that a plus x is less than bx. Okay, hence this is what we have. I want to start with bx minus ax, and then we're gonna have ax plus minus a times x, and we use distributive property. We're gonna have b plus minus a x. Then it turns out to be, what does it turn out to be? You might say that a greater than 0. Okay, a greater than 0 implies that x minus 0 is in the set of natural number. So we're gonna have b plus minus a times x minus 0. Okay, we have the product of two positive integers. So we're gonna have that this product is in the set of natural number. This is by trichotomy law, right? Okay. How do we say it? By trichotomy law. By trichotomy law. The second law. Okay. That's what we have. Alright. So now we have bx minus ax to be in the set of natural number. Okay. So therefore, bx greater than ax, and hence ax is less than bx. Okay, ax is less than bx. That's what we have, and this is the fourth property. All right, and the fifth property here. If a is less than b and x is less than 0, then ax is greater than bx. Okay, that's the last one. Let's prove this property. So we gotta have we have to assume that a less than b and x less than 0. Okay, right now we have less than. What can we do with this? Once we have less than, so we gotta have b greater than a. Okay, b greater than a and okay, x less than 0. Let me try this. So let's do it step by step. Since a is less than b, by definition of inequality, we're gonna have b greater than a. Okay, and hence b minus a is in the set of natural number. Now what about x less than 0? So we know that x is less than 0 and x is an integer. By trichotomy law, what does it imply? Okay, so trichotomy law, what does it imply? It implies that minus x is a natural number. Okay, it's a natural number. So once we have these two natural numbers, b minus a is a natural number, minus x is also a natural number. So what do we have? Okay, again we use trichotomy law. By trichotomy law, the second one. Okay, so we're gonna have ax minus bx. I want to start with ax minus bx, and then we're gonna have minus a times minus x plus b minus x. We want to have minus x because minus x is in the set of natural number. And then we use distributive property. We're gonna have minus a plus b times minus x. And minus a plus b is the same as b minus a multiplying minus x. Okay? And these are two natural numbers. The product of two natural numbers is in the set of natural number by trichotomy law. Okay? Hence, right now we have shown that ax minus bx is in the set of natural number. And thus, we have shown that ax is greater than bx. Okay? Alright, so we have proved property of inequalities of integers by using trichotomy law and definition of inequality. In the next time, we will use trichotomy law to prove this inequality. We've known that natural number, which is a subset of integer, satisfy trichotomy law. Okay? My question is there any other subset of natural number satisfying trichotomy law? Okay? So we will go to this theorem in the next video. Goodbye.